Okay, good afternoon, everyone. How did your homework go? So the way we start every lecture is, my first question is, how did the homework go? It means those practice problems I assigned to you. I basically expect you to have done them, struggled with them, and not with others. And when we start the meeting, you tell me which problems you had difficulties with, or it was confusing for you. And we go over them. Okay, so that's usually the way we always start. Once we take care of this, then I start the new material. So now back to you. Which problems you guys struggled with? You can put them on chat, and I look up, and then we can start with them. So please get going. Any questions from the practice problem I've assigned? Okay. And remember, that's the only way you're going to learn in this course. You know, listen to the lecture, do the practice problem, have difficulties, ask me, ask the SI, and that's how we're going to get through the material. So any questions from the homework? Okay. So we start that. And I'm going to pick up one of the problems, and I'm going to do it very carefully, unless you have anything specific yourself. But before I do that, I will introduce a word called the domain of a function. So domain of a function. So what's the domain of a function? Remember, the function is a rule. It takes certain input values, so certain object, as a zero, and assign to each one of them exactly one object. So that's really what it does. So to each one, exactly one, exactly one, exactly one. That's really the idea. The domain are all those input value, all of them. So it's a collection of them. There are a lot of them. All those input value, we give them a name, we call them the domain. So the domain of a function is the collection, or is the set. So the domain of a function is the set. It means the collection, the set of all the input value. It means this, the thing that we assign something to, input values. Now, how do we find the domain? It will be, at least for the first few sections, it's going to be given to us. Later on, we will find out how we will learn how to find it. So, but let me explain what do I mean. So, for example, let me take the following problem. Suppose I say, let f be the function. So you don't have to write this, but just listen to answer the domain. Suppose I say, let f be the function that is signed. That is signed. So that's my assignment. To each US citizen, the number of letters in their first name. The problem that we talked last time. In their first name. Okay. Suppose we have this story problem. What is the domain of this function? Okay. What is the domain? We're trying to understand the meaning of the word domain. So what's the domain of this function? Can anybody try to give it a shot? So the domain are all those input. It means all the objects that we assign something to. So what's the domain here? F assigned to each US citizen the number of letters. So if I'm thinking about the rule, what should go here and what should go here? What are the input and what are the output?
Your US citizens.
US citizens are the input.
Yeah.
The output are the number of letters. The domain is everything that works as an input. So the domain here is all US citizens. It means those input have values. They are objects, but what are they? we call them the domain. So domain are all those possible inputs, so all the US citizens. So there are infinitely many, not infinitely, there are a lot of them. US citizens, we have 300 million almost citizens in this country. So the domain consists in this particular of 300 million objects. Every US citizen is something in the domain. So that's what we mean by the domain of the function. These all those input value. Okay. All right. Okay. This being said, and you guys don't have any questions, so I'm going to work on number 9. Okay, because it's fairly important, number 9. Okay. So last time, most of my functions were basically given to you verbally. Okay, I told you, okay, let f be the function that every US is in the number of letters. Or we said, let f be the function that we put people in line. And we said the function said to every person, for example, it is signed in line, it will assign the first letter of their first name. So all of those were given verbally. But usually the rule is given different ways. So another way the rule will be given is by a formula. This is the content of number 9 that you're going to work on it very, very slowly because it is important. I mean, everything you're doing is crucial. So number 9 tells me the following. I read it and then we interpret. And you should have done it, guys, because I assigned it. Let A and B be sets of all real numbers. So 1, a half, 3/2, 3/4. F is the function. It is a rule that does what? To each element x in A, to every element in A, assign 3x squared plus 5. So another way of writing this is f of x equal 3x squared plus 5. So what are they basically talking about? They're talking about a function. It means it's a rule. What does this rule do? I keep this here so we see it. This rule is to every x in A. Now what is A? A is every possible real number. So to every possible real number, it's going to assign something. What does it assign? 3 times the number square plus 5. That's the rule. So you give it something, input something, it output. What does it output? 3 times what you give it square plus 5. And the way we write this is that f of x is 3x squared plus 5. So these are the input, those numbers. And for every input, the output that corresponds to it, or what we assign to it, is 3x squared plus 5. All right, so before we take up all the question, what's the domain in this scenario? What's the domain? What are the input values? We read carefully. Yes, please, Connor. Unmute yourself because I can't hear you.
Sorry about that.
That's fine.
Would it be all numbers?
Exactly, all numbers, all the numbers. Because if we read the problem, f is assigned to each element in A. A is all the numbers. It means here, when I'm drawing, I cannot draw anymore because here I should have every possible number. Not the possible numbers are not 0, 1, 2, 3. It's 0, it's a half, it's a third, it's a fourth, it's 1/7. So infinitely many of them. So the domain is all real numbers. Okay, and now we're going to start basically working with this function. All right, so part A. So we're going to do a lot. What is f of minus 1? So now my goal is to understand this function. What does f of minus 1 is? So what does this function do? You give it an input, whatever you give it, spits out something. What does it spit out? That's the way I read it. It's 3 times whatever you give it, it's squared plus 5. So that's the rule that this function follows. So what is f of minus 1? It's 3 times minus 1 squared plus 5. Okay, so it means minus 1 squared is a 1, right? So it's 3 plus 5 equal to 8. That's how my function works. whatever you give it. It's 3 times what you give it, square plus 5. Okay. So let's do 2 more along the same line. So I will do, for example, C. Okay. F of 1/2. What does F do? That's my input here. That's the input. What F do to anything? It's 3 times, multiply it by whatever you give it, square it, plus 5. Okay, so this will be equal to 3 times. Now, because it's algebra course, so whenever we have something like this, we're gonna actually try to write it as a fraction. So let us see. A half square is how much? Quickly. What's a half square? The chat is open. Nobody's writing anything on it. Get going. That's your participation point. What's a half square?
1, right?
It's a half. What's a half square? Let's remember. It's a half times a half.
1.
1/4.
1/4, right. Because it's half times a half. How do we multiply fraction? We multiply the numerator, 1 times 1, over 2 times 2, which is 4. Okay, so a half square is a half times a half, which is 1/4, times 1/4 plus 5. Now, 0.25 is correct, but we want to work with fraction. So a lot of times, and we're going to get used to that, I will tell you, express your answer as a fraction. It means I don't want you to use decimal because I want to practice working with fraction because you need them. Okay, it's easy to plug it into your calculator, but I really want fraction to be kind of practice again. I know you've learned it, but we're going to practice it again. Equal to, what's 3 times 1/4? Okay. Basically, 3/4. It's 1/4 plus 1/4 plus 1/4. That's what it is. It means 3 of them. Plus 5. Okay. Now, I want to write this as one fraction. How do we do that? If I want as one fraction.
Change 5 to a fraction.
What?
Change 5 to a fraction.
We're gonna write, I don't think I understood what you said. If I wanna write this as one fraction, what's the way to go? Do you remember?
Wouldn't you put a 1 underneath the 5
Right,
to make
and
it a fraction?
right, so we look for a common denominator, right? So 3/4 plus 5/1, that's correct. But now I want a common denominator because to be able to combine those, I need a common denominator. Otherwise, I can't really combine them. Okay, so what's the common denominator here? So I really would like to combine them and write them as one fraction. So I need a common denominator, which is going to be 4 because you have 4 and 1. The common denominator is going to be 4. So I multiply this by 4, I divide it. Now that I have the same denominator, I can combine the numerator. Now 5 times 4, this is it, 20. Okay. So, and this would leave me with 23/4. Okay, so when I tell you express the answer as one fraction, that's really what I'm expecting you to do. Okay, so I don't want decimal because decimal, you pick them up from a calculator. And the goal is to practice a little bit those simple ideas. Okay, so a half square, a half times a half, a fourth, I got here. 3 times a fourth, which is basically a fourth plus a fourth plus a fourth. It means it's 3 of them, plus 5. If I want one fraction, I need a common denominator, which is a 4. So I multiply this by 4, divide it. I have a common denominator, and then we proceed. Okay, so question? All right, very good. Now, so we keep working with this problem. Sorry, I lost it. Where is it? Oh, right there. All right, f of -3. And then we proceed. So f of -3 equal. Okay, I give you 30 seconds to find f of minus 3. And I write the function again. I write the rule. So you guys remember it. It's f of x equal 3x squared plus 5. Okay, so what is f of minus 3? I'm getting 32. Anybody else? All right, it seems that everybody's getting 32, so let me do it myself. It's 3 times whatever you give it here, minus 3. So times minus 3 squared plus 5. It means 3 times minus 3, it's minus 3 times minus 3, it's a 9 plus 5. It means it's a 27 plus 5, which is exactly 32. Okay, so that's really how we deal, how we find the output when the function is given by really a formula here. Now we're going to keep going. G, I read it. I give you a minute to give me the answer, and then we proceed. So those type of problem will come up a lot with us, absolutely a lot, and they come up with a lot of any math question. So the question here now, if t is any number, what is f of t? Again, I'll give you 30 seconds to answer, then I will pick one of you. Okay. Nick Martinez, what did you get? Nick, are you with me? Are you with me? Okay. Brandon? Brandon, are you with me?
Yeah, I'm trying to think.
Okay, good.
I'm just confused as of what it's actually like asking for. Like, is it asking whether f is a domain or is it asking if it's a valid function?
No, they're asking to determine what f of t is. So what is f of t? Anybody can answer, and I'll explain. I understand your confusion because.
Is it 8?
How much? Repeat.
Is the final answer or no?
8?
Yeah. Or
What did you
I put t would be 1. I substituted for, I don't know.
No, you cannot do that. You cannot do that.
You just plug in T.
Exactly. We just plug in t for x. You
Okay,
cannot
that makes
give-
sense.
Exactly. It's a simple question. It looks confusing, but it's not. You just plug in t for x. You cannot give t a value because otherwise I would put f of 1. I didn't do
Okay.
that. Okay. So the idea is that what does function do? Whatever you give it, input. That's how I see it. It is 3 times what you give it squared plus 5. Regardless what you give it. So you give it a t because that's what they want you to give it. It's going to spit out 3t squared plus 5. All right. So now they are trying to do those problems in a little bit more abstract way. That's it. That's the answer. All right. Now H. Okay, H. I read it and I'll get back to you. Is there a number C such that f of C equal 53? What are they asking for? And what are they giving you? So I rewrite the question to make it a little bit clear. What are they asking you for in this question? Very good, whoever answered. So I will pick one of you, for example, and ask, what do you understand? Tristan D. Are you with me?
Yes, I'm here. Yeah.
Okay, please go ahead. What do you understand by this question?
Um,
Remember, I don't care if
You-
you answer wrong.
Would you just
Go ahead.
divide 53? Or no.
No, we're
No,
not.
no, no.
Yes, we're going to understand what they want. And then we find the answer. What are they giving us? What do they want us to find?
C.
Are they giving?
Can we plug in 53 for C?
No, because 53 here, is it an output or an input value? Let's get that very clear.
Output.
What?
Output.
Absolutely. They want me to find what should I put in here? What value? When I put C of it, when I find what's assigned to it, I get 53. So 53 is an output value. And they ask me, why in this class always I have noises? I don't have noise in my other classes. So the question is, what is the input that I should put here that spits out an output of 53? So I see this question very important. I want to find C. C is an input here. That's what I want to find. That gives me an output of 53. The question is, how do I find this? How do I solve this type of problem? So basically here, what I need is, I want to find, so what is f of C? F of C is, this is f of C, because that's what f does. So this should be, that's what f does. And the question is, what should be the C so that when I do that, I get 53?
4.
4, did you guess or you solved?
I kind of.
Positive or negative 4?
Right. So we're going to set this, and did you guess or you solved?
I
Solved.
solved.
So very good. So we're going to solve all together. So the problem now is we need to find the C that make this equal to 53. Now the question is to solve. We're going to go after it. All right, the students are solving and I like what I see. How do we solve? First, we need to isolate. What?
4 in for C.
How did you get it? We're going to solve it because sometimes it's hard to guess it.
Okay.
So how you want to?
You have to
Sorry.
solve for C first to find the number.
So what do I need? I need to
Subtract the 5 to the other side.
subtract the 5. Isolate. So I subtract the 5. And this will give me
48.
very good.
Divide 3.
Divide by 3 because I need to isolate the C square. It will give me C square equal
60.
right? C square equals 16. So far, so good. And now,
And you square 16.
so C would be, no, you mean square root.
Oh yeah, my bad.
Okay, which give me C equal 4. Okay, we're almost correct. All right, almost, but there is something missing. And one of your classmates know what's missing.
It's a negative sign.
Not negative, it's both. It's either the plus
Oh, okay.
or the minus. So it means the C is either the plus 4 or minus 4. Why? Because if I take plus 4, I square it, I get 16. Also, if I take minus 4, I square it, it's 4 times minus 4, which is also give me 16. Okay, so C is 4, C equal minus 4. So I have 2 values of C that spits out an output of 53. Now we can check our work. I go back. Is 4 spits out 53? I plug in 4 for C and just check my work. 3 times 16, 48, plus 5, 53. So it's correct. I check minus 4. So I'm just checking. Do those spits out 53? So 4 did give me 53. What about minus 4? Okay. Is it spitting out 53?
Yes.
Yes.
Absolutely correct. All right. So let us a little bit recap because you're going to have a lot of questions along those lines. Find a C such that f of c equal 53. It means they are after the input that gives you an output of 53. How do we do that? I say, okay, I'm gonna set f of c, this is f of c, equal 53 and look for the c. So I'm not gonna guess. Then we solved verbatim. We solved very slowly. We solved very slowly, and then we get c is to 4 and minus 4. All right. So every question we have to ask ourselves: do they want me to find the input? Do they want me to find the output? You always ask yourself the same questions. All right. Let us proceed. Don't worry about I. I want to move back to J here. So I will read J. J is the following. If T is a number, so they're not given to you. So it's a represent a number. That's really what they mean. Find an expression for f of t plus 1 and simplify your answer. So what do they mean by that?
Hi. You just plug in either t plus 1 or t minus 1, depending on which one you want to solve. So this is t plus 1. Okay. So then you do 3 times t plus 1 squared plus 5.
Plus 5.
Yeah.
You guys agree with her? Anybody
Yes.
have any question?
Yes.
The function does. That's what it does. It doesn't matter what you give it. It's 3 times what you give it squared plus 5. Now I want to simplify our answer. And I'm going to do that slowly. Okay. What's t plus 1 squared?
T squared 1.
No. No.
You're right, x plus, t plus 1 twice.
It's t plus 1
You have to factor.
times t plus 1. Okay, it's not t squared plus 1. I will mention that in a second. So it's t plus 1 multiplied by t plus 1. This is equal to what?
Oh,
Yeah, it's not square plus 1. I'm going to do what? I'm going to distribute or FOIL, whatever you guys call it, but I prefer distribute. T times t squared plus t plus, I keep distributing, plus t plus 1. So it's not t squared plus 1. It's t squared plus 2t plus 1.
plus. Yeah.
Very, very careful. Very, very careful. Don't jump. So it's not t squared plus 1. It's absolutely not that. Plus the 5. Now, since they want me to simplify, I need to distribute. Again, I will have 3t squared plus 6t plus 3 plus 5. And this would give me 3t squared plus 6t plus 8. That's the correct answer. So the things that we've learned that the quantity t plus 1 squared is not what you want it to be. It means it's not t squared plus 1 squared. Absolutely false. We cannot just split them like this. That's the correct answer. That's how we do it. All right. Okay, now we're going to do f of t minus 1. And I will give you 1 minute to do it, actually less, and share the answer. And I will pick one of you to give me the answer. And I want it to be done absolutely correctly. I pick one. Zach, not look, Zach.
Yeah, I'm here, but I'm kind of confused.
Okay, what did you do so far? Fine with me.
I just wrote it down because I'm honestly not too sure what to do on this one.
Okay, so first, the first line, what should it be? Step number one. What is the input here? What's the input here?
T minus 1.
Okay, what does the function do to an input? Where does it send it? Are you
I'm
with-
not too sure.
What does it send it? So that's the rule. Let us analyze it one more time. Where does f send an input? Whatever you give it.
Would it be to 3x squared plus 5?
Yeah, but what's my input in this scenario?
T minus 1.
So it means if you put t minus 1 here, f will send it to where?
3.
3.
And t minus 1 squared.
Keep going.
Plus 5.
Plus 5. Okay, so that's what will f do to anything between the parentheses, whatever it is. It's t minus 1, that's what's going to do to it. So it's 3 times t minus 1 squared plus 5. Does this make a little bit more sense?
Yeah, a little bit.
Okay, so that's what f does. I mean, in a more abstract way, because we have to learn how to deal with function symbolically. It's crucial. I mean, this whole course is about function. So that's really what it does. Now I want you to simplify that. It means like I did the previous one. But this is algebra, not more, nothing else, basically. It's basic algebra right there. Yeah, I'll give you 30 seconds by now because we have to keep going and give time to everybody else to finish it. And for those who are done, I will do one more. It's not in the book, but it doesn't really matter. I want you to give me f of 2t. For those who are done, find an expression for f of 2t. Are you guys done with f of t minus 1? Can anybody share their answer with me? The student who was working with me, did you get it?
Okay, so wouldn't it just be 3t minus 1 plus 5?
This one?
Yeah.
No, why? On what basis?
Well, then you'd simplify it to 3t plus 4.
No, why?
You got to square.
You have to square first.
Oh,
Yeah, your classmates sometimes are immediate. So you have to square first. Okay, you have to square first. And then you have to multiply the whole thing by t minus 1. So let's do it again slowly. What's t minus 1 squared? It's t minus 1 times t minus 1. I do it on the side so so to be clearer for you. It's equal to what? So first you have to square this. After you square it, you multiply by 3. So let us see this give me what? T times t squared minus t minus t minus plus 1. So this will give me t squared minus 2t plus 1. So this is 3 times t squared minus 2t plus 1 plus 5. So first you have to square the term. Then we have to multiply every term by 3. Now I distribute the 3. which will give me 3t squared minus 6t plus 3 plus 5. We do it very, very slow. We don't jump. Every step should follow logically from the step before it. And finally, what do I get? Minus 6t plus 8. Okay? Now, the last one. So we're working with functions symbolically in this problem. F of 2t. Again, I'll give you a minute and then I will pick one of you and see what you guys have got. Always ask yourself, what's this function doing? Give it something. So I'm working with the same function exactly. What should it spit out?
Two T.
I'm listening.
Six T squared plus 8.
How much? I'm gonna write what you got.
6T squared plus 8
3
times 2T squared.
okay, you're giving me that. Here. 3 times.
2T squared
And where the parentheses should be?
inside of
Where do you want me to start my parentheses?
2T.
After 3.
Yeah. Squared plus 5. So
Plus 5.
equals 6T squared.
No. Why not? Here,
You
quantity 2t squared. Again, I'm going to move to the side and evaluate it. What's the quantity 2t squared? What does it mean?
2T, 2T.
It's 2t,
Plus 2T.
No, isn't it 4t?
right, times 2t.
Oh, so you don't multiply the 3 to 2?
You can't multiply the 3 to 2 because the 2t is between parentheses. It means the 2 itself is being squared as well.
Oh.
Are you with me? I mean, all of you, sorry. Now, what do I get? 2 times 2, it's a 4.
Yep.
4T squared. Yes.
Okay, so now I'm going to have 3 times 4t squared plus 5.
12T squared plus 8.
There is no 8, actually. There is no 8.
Oh, I thought you. Oh, okay, never mind. I thought you do 3 plus 5.
No, because it's 3 multiplied by 2t squared.
True.
Okay, got it.
It's going to give me how much now?
12T squared plus 5.
Plus 5. Now I am done. Okay, so please do the algebra very slowly. Don't jump. The minute you jump, you're going to do mistakes.
I have
Yeah.
a question.
Yes.
So when we're combining initially, when we're working the 2t squared that's inside the parentheses,
Yes.
we make it to 4t, we keep it 4t squared, correct? It's not, we don't drop the squared, right?
No, how? How can you drop it? No. Keep it for t squared. Exactly. It's t times t.
Okay.
It's t times t, right? So this will become like it's 2. You can switch the, like, this is like 2 times 2 times t times t. It's the same thing.
We didn't do that whenever we did F parentheses T plus 1. It was the same process, but we didn't.
Yeah, it's the same process. It's all the same process, but it depends what you have inside for input. So when I had t plus 1, I basically evaluated t plus 1 times t plus 1. In this case, I distributed or I FOILed t times t, which is t squared plus t plus 1 times t plus 1 times 1, and I got here. Okay, here I'm doing the same, but I have a different quantity that I'm squaring.
So the fact that the 2 is in there, that's the one that changes it.
Yeah.
Okay. Thank you.
Please go over that very carefully because it's, you know, it's everything we do is crucial. Right? Any other questions? Right? So you have go over problem number 9 again and make sure you can do it correctly. So today we keep along the same line. I'm not really changing the picture, but we're going to talk about the graph of a function. So this is section 1.3 in the book. And it's the graph of a function.
I have a question.
I'm listening.
So are we gonna have to know how to solve K and L on number 9?
Let me see, what are they about? If I didn't do it, you're okay. Don't worry about it. But let me see them. Let me see them. Don't worry about them. Don't worry about them. Okay.
Okay.
Yeah, I want you to focus now on how to work with functions symbolically, what I did in class. Okay, don't worry about that now. The graph of a function. As I said, function is a rule. We give it an input and it spits out an output. And so far we did two types of function. Once verbally, let f be the function that is assigned to every student, whatever, their social security number, for example. So this is a verbal way of talking about function. Another way that a lot of time functions are given by a rule. So like the one we did, give it x, and the function spits out 3x squared plus 5. So the rule, that's the rule that I give it to you. Sometimes the function, the rule is given by a graph. So rules, functions given by a graph. Now what do we mean by that? Now, I'm sure that you guys have seen this, but you have, of course, to study it again. Functions given by a graph. What does this mean? It means a function where a graph, it means a picture, more or less, gives you the rule. So let us see what we're talking about. So I tell you, let f be given by the graph below. Let f be given by the graph below. What does it mean? What am I talking about? So I'm gonna go here and I'm gonna draw a graph. It means just something like a curve, no more, no less. So this is, let us say, -2 and 1, 2, 3, 4, 5. And I'm gonna draw a graph. So something like that. Okay, I'm gonna stop right here, and this is 5. Now, when you have a graph, it means you tell a function given by a graph, which is nothing more than the curve. On the x-axis or on the horizontal axis, that's where the input values are. So the input values are always on the horizontal axis. Always. Okay. Now, how does this picture give you the rule? Give it to you like this. Suppose I have a 1 here. What is f of 1? F of 1 is the following. What's the rule? You go from 1, you draw the line, the vertical line, till you hit the curve. Okay, from 1, suppose I want to what's f of 1. How's the rule given? From 1, you draw the vertical line till you hit the curve. You hit the curve here. This point has a y-coordinate. The y-coordinate is what f of 1 is. It means from here to here, this is the vertical distance. This is f of 1. This point here, 1 is the input, and this is the f of 1. So that's how the rule is given. So if I give you an input of 1, what's the rule if you have a graph? It's the vertical distance from 1 till you hit the curve. So this point here is f of 1. I'm not giving you numbers on the y-axis on purpose. We will have a lot of numbers later on. But now that's the idea. So if I tell you what is f of 3 on the picture, you go from 3, take the vertical line till you hit the curve. This point here, that's a 3. The second component is the rule, is the f of 3. So the rule is this distance from here to here. So if I have a scale, whatever the number here on the y-axis, this would be my f of 3. So if I have So let us say this is 4.5, for example. What's the f of 4.5? I go vertically till I hit the curve. This point, whatever the y coordinate is, that would be the f of 4.5. So that's how the graph is defined. There are all the points. So let me ask you a question. Suppose I call this C, just for the sake of it. And I'm not gonna give it a, I don't know, a value. This point here, from here to here, this is f of C, okay? So this point here, C, the input, and this is f of C, the output. Okay, so that's how the graph is. That's how the rule is given by the graph. So if I want f of 1, I say, okay, this is 1. The vertical distance that I hit the graph, this is f of 1. F of 5, this is 5. Take the vertical line till I hit the graph. Whatever I get here, the y coordinate here is the output that corresponds to 5. Now, in this particular problem, suppose I ask you the following question. If you don't understand, let me know. Is -3 an input value, do you think? Yes, do you think I can find an output for -3? What do you think?
Yeah.
This is -3.
Okay.
The picture I gave you, can you tell me what f of -3 is? According to my picture, you should draw the line where till you hit the curve, but there is nothing.
So it wouldn't be a value?
It will, what? So it's not an input value. It's not an input because I cannot tell you what f of -3 is. The graph doesn't show it to you. So -3 is not an input value. 6 is not an input value in this particular picture. So in this graph, the domain, it means the input value is going to be everything between -2 and 5. Because for those, you can tell me what the output is. For the other, because I don't have anything here, there is no output. So they are not domain. So the domain will be all values of x, such that x is between -2 and 5. This would be my domain. All those input for which I can find -3, there is no graph here. There is nothing here. So there is no output for that. So this is not an input value. So now we're going to work with that. I'm going to give you 2 examples in front of us, and then we're going to have a worksheet to basically practice those ideas. So example number 2 is going to be the following. Okay, example number 2. Then I give you the graph of a function like this. So 1, 2, 3, 4, and -1, -2. So I'm labeling, and I'm going to label that this time 2, 3, 4, and -1, -2. Now I'm going to make the following graph, which is going to consist of a bunch of points. So I'm going to put a point here. This is my graph. And I'm going to put a point here. So here my graph is a bunch of those points. And for here at 3, I'm going to give it the value. Okay, and right there. Okay, so that's the graph, which is a bunch of points, those points that you see. So what do I mean by that? Let me start asking you questions. So that's the graph of a function f. Now, question. According to this picture, I want you to find f of -2 f of 0, and f of 4. So I'm telling you, this is the graph. What is f of minus 2? Okay. All right, I'm getting one answer. Do we agree? So this is minus 2. I say, okay, the graph is bunch of points. That's all right, no problem. From minus 2, I take the vertical distance till I hit the graph. From minus 2 to here, according to us, this is equal to 1. F of minus 2 is 1.
Oh,
What is f of 0?
3.
3.
3. Okay, are you correct? Absolutely. What is f of 4?
-1.
-1.
Right, this is 4. This is the f of 4, the y coordinate, which is minus 1. Very good. Question number 2 is, find, now it's my question, find all values of C such that f of C equal to 1. What am I asking you for? What am I asking you now? What am I giving you? And what am I asking you?
Are you asking
Between
which
1 and 2.
input is equal to 1?
Right, I'm asking where, repeat. There is noise in the background. I don't know why. That's weird. It's only in this class, as I said. Repeat, please.
You're asking that which input is equal the output of 1?
Right, which input gives me an output of 1? Absolutely correct. I'm asking for those, the input that gives me an output of 1. Okay, now I go back to my picture here. Which are the input that's giving me an output of 1? So the output of 1 means this should be here, the output. Which ones?
1 and 2.
1, 2. Are those the only one? What else?
And -2.
Because this is my 1. Okay, this is my 1. This is the point on the graph. This is the point on the graph, and this is the point on the graph. So I go ask myself, okay, what are those input? That's the -2 from here. That's the 1, and that's the 2. Okay, so the domain, sorry. So C is -2, 1. Okay, my last question is, what's the domain of F? It means what are the input value in here? What are the input value? It means, let me ask you a question. Is -3 an input value? Do you have an output for -3?
No.
No.
No. Is -2 an input?
Yeah.
Is -1.5 an input?
Uh-huh.
No.
No, because -1.5 is here. There is no graph here. There is nothing. So if I tell you f of -1.5, you look at me in the face. You tell me, I don't know. You don't have a curve in here. I don't know what it is. So that's not an input value. So what is the domain? The domain are all those input values. What's the domain in here? -2, because I have f of -2. I know what it is. -1, yes, because f of -1 is 0. Anything in between in this particular problem, I don't have an output for it. 0, it is in the domain in this problem. 1 in my domain, 2, 3, and 4. So my domain here consists of 1, 2, 3, 4, 5, 6, 7. Only 7 numbers in this particular problem. Okay. All right. One more example. And then we work on the worksheet. One more example. Simple. I'm sure you guys will be able to answer it without any difficulty. I'm going to give you a graph. Again, I'm making a couple of graphs. So I'm going to give you this graph. Very good. So that's a graph. And the question is the following. Is this the graph of a function? Yes or no?
Yes.
No.
No. The one who say yes, see what's happening. Why yes, why no? Okay, Adriana, why no?
Because one has two outputs.
Exactly. It's absolutely no. Because if I tell you what is f of 1, okay, there are two dots here. So if I take the vertical distance till I touch the graph, I can touch it here or here. So I have 1 has two outputs. 1 and 2. It goes to 2. Therefore, it's not a function. So to be a function for every value here, I should have exactly one output. So the graph cannot cross each other. You cannot have, so this type of graph is not the graph of a function because for one input, I can have 1, 2 output. It's not the graph of a function. Because the function is this rule. I mean, it's a very specific rule. Input have exactly 1. So input goes to 1 output. It cannot go to 2. The minute it start going to 2, that's it. I'm done. That's not a function. So it's a very specific meaning for that. Now I want you to, as usual, we're gonna go to, like we did last time, we're gonna practice those ideas. And on Brightspace, you have something called worksheet for section 1.3, which is the one I have in front of me. But I put on Brightspace, so in case you can't see clearly, you guys can see well in front of you. And so pull it up, please. So it will be very clear for you. And so this is a graph of a function right there. And so this is so -3 is here and 5 is here. Okay, questions. This is the graph. Find f of -3, f of 0, f of 1, and f of 2. So I'm going to give you like whatever, a minute at most to find the answer. Then I'm going to pick one of you and ask them what did they find out. So this is -3 is here just to make sure. Yes. Are we ready? Okay. Mia, are you ready? Mia Davis, are you ready? Mia?
It's Maya.
Oh, I'm sorry. I hope to remember next time. Maya, are you ready?
No, ma'am.
Okay. Any of them? F of -3.
It would be 12.
12. You guys see? Okay, let's see.
Oh.
-3. I'm gonna take the line, the vertical line, till I hit my graph. That's what I do. This point here.
Oh no, 10. I mean, right? 10?
Oh, no, you're right. You're 12.
Oh, it is 12? Okay.
It's not 10.
It's 10, no?
Okay.
Well, if you zoom in,
Yeah,
Yeah.
if you zoom in, it's gonna be 12.
yeah,
Yeah.
Oh, my bad.
Oh, that's okay. It's probably the graph, not you. So it's equal to 12 because that's the second coordinate. F of 0. Maya, do you think you can do f of 0 for us?
No.
Okay. What is 0? Remember, 0 is an input value. If it's an input value, it means it's on the x-axis. That's my 0. F of 0, which is the output value, to find it from 0, we take the vertical line till we hit the graph. Now, when
so
we
it's
hit,
-3, right?
then it's -3. Absolutely correct. This point here, the red, this one, the first component is a 0, that's the input. And the second component is the output that corresponds to f of 0. That's f of 0, which is exactly -3. That's point right there. Now, f of 1. 1 is the input. 1 is on the x-axis. All right. Let's see.
Negative.
Sorry. Okay. Kyle Fritz. Kyle, help me out. What's f of 1?
It would be -4.
Agree with him?
Yes.
Yes. This is 1 in input. We go all the way till we hit the curve. Right there. So this point here, that's -4. So this point is the 1, f of 1. What's f of 1? Is exactly -4. Finally, f of 2. And let me pick somebody. Lateral Lewis.
I'm gonna be honest with you, I don't know. I'm just following along.
Okay, let's do it together. That's why I'm picking on you, because I want you to follow me. The 2 is the input value, right? The input value
Yes.
goes on the vertical axis. I focus on the 2 right there.
Okay.
That's it. F of 2, what do I do? From 2, I do what?
You go down.
Right till
You're
I
going-
hit the curve, the graph.
Okay.
Point 2 is the first coordinate. Whatever the second coordinate here, this is what
Is
we
that 3?
which is not 3.
Minus.
-3. Because if you
Okay.
go here, that's
Right,
-3.
negative.
Right.
Okay.
F of 2 is -3.
Professor, I have a question.
Yes, please go ahead.
How you know when to go down and come up?
I take the line till I hit the graph. So it depends where the graph is. So let us pick points arbitrarily.
Can you
Suppose I want f of 4. Okay?
Okay.
4 is an input. It means 4 is on the x-axis. That's 4.
Yes.
Then you take the line till you hit this graph here. That's what you want to hit. Now, do you have to go up or down till you hit the graph?
Up.
Up. So from here, we go up. I hit the graph here. Are you with me so far? Are you with me so far, or you lost me?
Oh, okay, I got it.
Now, this point has 2 coordinates. 4, that's your input. That's what you give. And the second coordinate is the output. So the output here is going to be 5. This is the f of 4. Okay? So now let me ask you, for example, one more before I proceed.
I got one more question.
Yes, I'm listening.
Go back to the f of 2, okay? You said it's -3.
Yes.
Why? You could have stopped under it, no? Because
I have to stop when I hit the graph. No way out.
yeah, but if you go one more down, you still hit the graph.
No, I hit it right here. That's the graph. If I go down, I hit nothing.
Okay.
All right. So let me push you one more. Give me, for example, f of, let me see what's a nice value in here. I don't know. give me f of minus a half. It's not a very nice value, but it's an approximate.
Yeah.
Give me an approximate value.
2
How did you get here?
minus.
Where is minus a half first?
Minus
Where's
4.
minus a half? It's right there. That's minus a half.
Minus 2.
Okay, you go to the x-axis. That's minus a half. How do you find f of it? From minus a half, you take the vertical line till you hit the curve. That's the curve. This curve, this something that's curving. That's what I mean by the graph. You go till you hit it. You're gonna hit it right there. What's the y-coordinate of this point? Almost.
1/3.
How could it be? It's a negative number because it's below the x-axis. Okay, so if you go there, this is minus 5, that's minus 1. This is almost.
Minus 2.
Minus 2. So you have to go down, you hit the curve. That's a negative number because you're below the x-axis. So the y-coordinate is going to be a negative number.
I got it.
Okay, f of minus 2 quickly, and then I move on.
The class is over.
F of minus 2, very quickly. Minus
That's
2.
5.
5.
Right, it's right here. You go till you hit curve. You hit it right there. The y-coordinate is what we call f of minus 2. Is this better?
Yeah.
Yes, ma'am.
Now, question number C. Sorry, I'm gonna scratch those. I want to scratch what's confusing. Find all numbers such that f of c equal to 0. And now I want you to ask you always the question, what am I looking for? The input or the output? And what
Which
am I
one are we
Input.
doing? B? Is this
C.
B or C? C?
I thought I scratched it. Okay.
Wouldn't it be 3 and -1?
3 and -1. Is she correct? I really don't know. What are we looking for? You are correct. What are we looking for? Input or output?
Input.
Yeah.
No.
The input.
We're looking for the input that spits out which output?
0.
So what are those input? Where it means basically I'm looking for those points on the graph where the y-coordinate is 0, because that's really the output are the y-coordinate of the point on the graph. So now I go back. Which input? The output is 0, -1,
3.
and 3.
3.
Absolutely. So C equal -1 and C equal to 3. So sorry, scratch B, D, and F because I don't want confusion at all. Now, what's the domain of F? It means if you look back at the graph, which input you can find in output and which one you can't. And assuming that the graph stops here, it doesn't go on forever. What's going to be the domain? Exactly, everything between -3 and 5. Because if I give you -4, ask what's f of -4, you look me up in the face, you tell me, but there is no graph here. So if I take vertical, there is nothing. So the domain are all values of x between -3 and 5. Okay. Now I want you to turn the second page and we're going to do another problem along the same line. So it will be very clear for us. Absolutely. Turn the page.
Professor Elias, is there a way?
What?
Is there a way that like I can keep your screen like on yours? Because when others are unmuted, it like I can't see the notes.
Yeah, click on it and push pin.
I appreciate you.
Oh, thank you very much. Because sometimes you guys understand each other better than I do. All right. Again, below is the graph of a function f. Answer each of the question below. I hope this is going to go faster. F of -1, f of 0, f of 2. Again, I will give you 1 minute and then I will pick one of you and I want answers. Now, based on what we did, I hope this is a bit easier.
Okay.
Elizabeth Royer, are you comfortable?
Kinda.
Okay, give it your best shot. F of -1, what did you get? And then I'll explain it as you're talking. What do you think you got?
0.
Elizabeth? First, your -1. If this is an input value, so you should see it where, that's where you start. You put on the x-axis, that's your -1. Okay?
So would it be 0?
Yeah, don't be afraid. It's just 0 because it hits the graph. Because at -1, the graph intersects the x-axis or it crosses the x-axis. So it's absolutely -1. Absolutely correct. Keep going. What's f of 0? Step number 1, you locate 0 on the x-axis. So the input are always located on the x-axis, located here. And then you ask yourself, I mean, you take the vertical distance, but here, again, at 0, we're crossing the graph. So what's f of 0?
0?
Elizabeth?
Is it 0?
0, right?
Yeah, absolutely, because that's what we cross the graph. What is f of 2?
6.
Because what do you do first? Put 2 on the x-axis. Second, from 2, you take the distance, right, up till you hit the graph. This is what f of 2 is. This is the y-coordinate of this point. So this is 6. So the y-coordinate, so this is 2. This is what we mean by f of 2. This is equal to 6. Okay. All right, let me do one more. What is f of -2? Elizabeth, can you figure this out? I think you can. Give it your best shot. Okay.
That's 5.
5. Okay. This is -2. I first located. The input, I always locate on the x-axis. Then I take my vertical line, I take it, I take it, I take it, I take it till I hit the curve. Now, if you guys have the graph physically in front of you, you can see it better. It's actually
It's 6.
It's 6, not 5. Okay, so when you guys
Sorry, I have a question.
I'm listening.
The f of -1, why would it be 0? Wouldn't it be negative, like,
0.5.
oh wait, yeah, negative 0.5 technically, because it's like halfway down.
Let me see in my graph. It seems that I am hitting.
Because the 0 is on the axis, right?
And -1 is on the axis. That's not how it looks to you.
The graph is
These
weird.
graphs
You
are
have to go every
weird.
2 over. So from -2 is, yeah. Like
That's
that.
the -1.
I'm saying the f of -1, if you go down to hit the graph, it's on ours, if you like zoom in, it shows that it's at like 0.5.
Yeah, these graphs are.
Like maybe I could
The graph
take like
is
a.
weird. It's
all
going
right, I
over by
understand.
0.5.
Yeah. When you have it in front of you, you will see exactly that it's going to be a 0 because I think I constructed the function. I remember what I did. Okay, so you're right, I understand. If it sets a little bit below, so what you see is the following. You're seeing something like that, right?
Yeah, if you zoom in though, she's kind of right.
So you're seeing something like this. Now, if that's what you are seeing, okay, then you are, if that's what you are seeing, you are right. Okay?
Yeah,
So when
exactly.
you have, right, when you have the graph physically in front of you, you will be able to see it as a 0. But if that's what you see, you're correct.
Okay. Yeah, I see. I understand like how it's different. I was just confused, but I
No,
understand now.
if that's
Thank
what
you.
you see, you are right. Okay, now B. And then we have to finish. Find, because I have to introduce your SI. Find all number C's such that f of C equal to 3. What am I asking for? What you have to find. You almost found them anyway.
What are you asking for?
B.
Oh,
Isn't it finding all the inputs that equal 3?
Exactly. Find all the C's such that f of C, it means I'm looking what input is giving me an output of 3. So 1. Okay, I'll write down what you give me and then I'll check because I don't do those before you. What else? That's the only one you gave?
Would
I
one of
think
them
so.
be -1/2? Because like towards like a little bit after the -2, it looks like one of the points. Oh wait, no.
I will go back with you. What is 3? 1, 2, 3. That's 3. Am I right? I want to look for all the points such that this happened. So basically, which are the points on the graph where the y coordinate is 3? This
-2.
And this point. You see them?
Yes.
Now, what are the x? What are the input that gives me this point? Now I go back here. This one here, that's the one you got. C equal to 1 is correct, but that's not the only one.
1.-1/2.
Yeah, something like this, the point here also. So now let us estimate this point. Okay, this is -1. And remember, every 2 square is a unit. So 1 square is half a unit. So that's a -1. That's -1.5.
Not 1.75.
That's 1.75.
Correct.
Right? So find all the input that are sent to 3. This is my 3 here. I go back and I check the point on the graph where the y coordinate is 3, and then I go down. Which one those are coming from? Which one those are coming from? And I proceed. Okay. So for Tuesday, you will have your first quiz, which will cover everything I did today and last Thursday. And I want you to do some practice problem and finish the worksheet for Tuesday. And
Do we have to turn it in?
No, no. You just ask me questions and we go over it in class. Okay.
You mind scooting down to the bottom of this paper?
I will.
Thank
The
you.
worksheet is on the bright space, so you guys have it there, so you can finish it. Now, the last minute, sorry, I have to introduce your SI. Emilio Novales, can you please show up your face for them? I can pin you down if I can find you.
There. I have my camera on. Can you hear me?
Yes.
Oh, man.
Okay. Dr. Elias, can I share my screen so I could post the
Yes, please
information?
do. Go ahead.
Okay. I think you have to enable my share.
Let me find you. I'm looking for you. So, okay, raise your hand so it will be easier for me to find
This
you.
will be good. Let me see. I don't know.
Ah, here you are. Here you are. Here you are.
There. Okay.
Okay, I'm gonna make you the co-host.
Okay.
I think, try it now. Can you pin yourself down?
Let me see. No, I still don't have the permission to share yet.
But you're not on the camera anymore.
I should be.
I see you.
Did I lose you? Did I enable somebody else?
Possibly. There's my hand again. So if you want to look through
I don't know who I
the
enabled.
participant.
Okay. All right. I'm sorry. I'm slow at that.
No, it's okay.
Where are you? Raise your hand again.
There it should be. It should still be up. There. I'm gonna put it up again.
Well, I'm not. Ah, here you are. Okay. Here you are. Thank you. So I'm gonna make you a host.
Okay.
You are the host. This should work.
Okay.
Okay. Here we are.
Okay. Thank you. So I'm gonna post the information. So I am your SI for the semester, and so to give you a little rundown of what we do. So I'm not a tutor, but I'm like I facilitate study groups. And so this isn't like, you don't have to pay for this. This is a part of your tuition for free. So we're just going to review concepts from the lecture. We're going to practice some of the problems that your professor will provide on Brightspace. We can work through those together. And then we'll learn how to use other resources. There's some websites that I want to show you guys that are really helpful to doing problems that you could use in future classes as well. And then I'll also answer some of the questions that you have from the lecture. So if you have any questions that come up after your lecture time, then you could bring them to the SI sessions. So according to the survey that I posted, I only got 10, or I think I got 12 responses. We'll be meeting Tuesdays and Thursdays from 5 to 6 p.m. So if that doesn't fit in you guys' schedule, again, you can email me at the email that I provided below. And then here I have the Zoom link where we'll be meeting, and I'll post all of this information on the Brightspace on an announcement. But if you guys want to screenshot this or take a picture, you guys can feel free to do so. And our first meeting will be Tuesday at 5, and it'll only be an hour long, so you guys can feel free to join me. And again, I'll post an announcement around the time of our first meeting. So that's all I wanted to share with you guys. So thank you for listening to me. And I will hand it back over to Dr. Elias.
Professor?
Yeah, here we are. Yes.
I got it.
Are we getting graded for the quiz on Tuesday?
Absolutely. Yeah. Yes.
I got a question.
Yes.
Where do we turn it in?
What?
Where do we turn it in?
The way I do the quizzes is I will put the quiz on Brightspace. Okay, so you guys will open Brightspace. The quiz will be there. You write your answer on a very nice, clear sheet of paper, and then you will upload it into Brightspace.
Oh.
So take a picture of it and then send it to you?
Yeah, you upload it into Brightspace.
Is the quiz like during class, or we could take it
Yes,
one
yeah,
at a time?
we're gonna do it in class. I want you to do it in class, okay? So the last
How much time do we have?
What?
How much time do we have?
You will have like 15 minutes to take the quiz, and you will have like 5 minutes to upload it. Okay, so practice upload. So the first day, the first quiz, I will give you more time, than usual. So you get into the habit of uploading, because, we may have, it's the first time. So on Tuesday, I will give you plenty of time to learn how to upload it. But after that, once you get it, then I will give you less time. Is that clear?
I know someone commented and they asked how many questions. Do you know how many
I really
questions?
don't know, because I write the quiz the night before. So ask me on Monday at 11 o'clock p.m. I'll answer you. Don't worry about it.
I have a question about the homework.
Yes.
So the worksheets are just the practice stuff, right?
Right.
But
right.
when does the real homework that's due start?
I hope next week, because it's an online one. Online.
Okay,
one.
and that will be uploaded on Brightspace, right?
No. It will be like a remember, like in high school, like a computer it's like a homework management system.
Okay.
Into it, and you will have the question, and you'll have 5 tries. You try the first time, you can't do it. You try the second time, and so on and so forth.
Okay, so we'll create like our accounts.
Yes. I will send you all the info.
Okay.
All the
Okay,
info will
thank
be
you.
sent hopefully over the weekend. But I
Okay.
rely a lot on the practice for the quizzes. For me, the practice problems that I'm giving you are crucial. That's
Okay.
a lot of your learning. So please do them.
Okay,
Any other
thank you.
questions?
Take your time with the homework. It's fine.
Yeah. Any other questions?
Yes, the quiz is just gonna be the things that we covered, correct? Like nothing extra.
Exactly. What we covered. Yes.
Crazy.
Yeah. It's what we covered. So make sure you go over them. Make sure you go over them.
Lesson is
And
you
what?
upload lessons already, yeah?
I'm not understanding the question.
Have you uploaded the videos from the lessons that we
I did for the one on Tuesday, and for the one today, no, of course I have